Hello everyone, my name is Shivam Singh and welcome back to the channel. Today we'll discuss why we invent math. You know, why we invent math, what, how, and what it helps, right? So first we'll talk about number system. What happens? The earlier civilization of human society has to count things. Has to make the record of it, or had to count in order to quantify things. So in order to quantify things, they had easier method was counting. And to remember things in accounting, they use their finger system. So most likely the decimal system we got is because of, I'm so sorry about my drawing, I think it's 5 5. Okay, so we got the 10 scale decimal system, and later invented zero, and the representation of 10 numbers got evolved. Like if I have to represent numbers, we can represent this way, 9 and 10, and for 11 we can add 10 plus 1, 10 plus 2, right? And let's say if it goes to 100, then we can say 100 plus 1, this way. So this is nothing but 100 is 10 times 10, 90 means 9 times 10, 92 means 9 times 10 plus 2, let's say 192. That would be 100 times 2, sorry, 100 times 1 plus 10 times 9, 9 times 10 plus 2. So this is the decimal system of writing. Even we can write 10.10. This would again will go on 10 की power minus, right? We can represent it like power minus 1 के format में लिख सकते हैं, and then we could write any general form into 10 की power 3 x digit, or 10 की power 2 into y digit, and then 10 की power 0 for the unit decimal. So this becomes the principle for decimal. Similar way, we have the binary system. Binary system is nothing but, let's say we have only two fingers and we are comfortable only counting two numbers, that is 0 and 1. This is off, this is on situation. So the system is used in computer or electronics because the current can have only two forms. So that way this becomes very important. So current, if current is not there because of potential, this is 0 state, this is 1 state. So in one bit we can store either 0 or either 1. So one way, this is 0, this is 1. Now to represent 2, how we can do? We don't have 2, we have only 0 1. By using 0 1, how we can use make 2? So since this is 1, right? So we can write this way as 2. And then this becomes, you add one more, this becomes 3. This is not 11. So that means whatever we have to add, this becomes the 2, right? So whatever number comes, we have to add 2 and then goes beyond. Like let's say we have to represent 3, then we have to add 1 at unit plus 2 at the position, right? So it becomes 3. That way if you want to write for 15 or 17, can goes like 15, 16. If we have to write 16 in a binary system, how many 2's we can form? How many 2 we can have? 8, right? 8. So we have to represent by just by dividing 8 to 4, 4 to 2, and 2 to 1. So 1 we take at 1. Here it becomes 0, 0, 0. So the number becomes 1 0 0. Why? Because when we divide the 16, we take the unit side here, right? So this becomes similar like hexadecimal. So decimal, they have 0 to 9, and they'll have A, B, C, D, and till H. Uh, so 6 letters here. I think it's go F, and 10 here. So it becomes 16 base. Right. It's very important in used in memories address like let's say AF38 or something like that. It's a very low level programming language that deals with machine. It's easy to convert it into binary rather than decimal, and it also helps to represent the ABCD. Why? Because it's 16. It's kind of easy to convert into twos, the binary system, and also we have letters. So it becomes very suitable for low level language. So I was talking about the math invention. So so numbers being formulated as even number, odd number, prime number, right? What is even is nothing. In Hindi we call it sum. That means symmetry. So for any thing to be symmetrical, it should have the quality of number 2. So if we divide any number by 2, then it will become even if it is divisible, and if it is not, then any extra number will make it not. Prime is nothing but any number, any sort of number, is made up of prime numbers. Prime numbers are the primary number, so to say. Any number can be formed using the prime numbers, right? And that way we have irrational number. Irrational is nothing but where you can't rationalize it. So if there is a rational number, there are also rational numbers. So irrational number is nothing but you can't rationalize it, like you can't put it into p by q form, because they have non-repeatable and never terminating numbers like pi, e, under root 3, under root 2, golden number like 1.61, dot dot dot. So you can't rationalize it, right? That's why they have irrational numbers. And except all those numbers who are rational, those can be formalized into p by q fraction form. We have whole numbers, natural numbers, integers, fractions, negative numbers. So negative we have invented, Natural numbers are all numbers who are present in nature. Whole numbers include 0 as well and a natural number, because of 0 being the complete number, right? Wholeness means that it doesn't have fraction. But 0 being invented later on and it's not present in nature, it is called whole number. Integer we know there could be a positive integer, there could be negative integers, right? These are also similar to whole number. Negative numbers are invented like, let's say for example, you have one car moving at 10 meter per second. To stop it, what you need to add or what you need to multiply? You need to multiply with 0. You need to add minus 10 velocity, meter per second velocity. So it will become 0. So these are, or you can say what we should add that it becomes 0. So it will come. So these negative numbers are very important, and they have been invented and formulated and conceptualized to handle some of the problems which needs the direction change, which we can comprehend, right? That way they have, mathematicians have invented imaginary number too. So imaginary number, let's say you have a car, again it's going 10 meter per second. What we should multiply or add, or so it gets 90 degree rotated. So for example, let's say that number is I. We multiply to 10 to I, it will become this. But we don't know what is this. But if we multiply again, this will become minus 10. So if we multiply I again, that number will become minus 10. And then I square will become minus 1, I is equal to under root minus 1. This has been the definition. So see how for convenience mathematicians invent these numbers, define these numbers. It's not that this is imaginary. In the calculation, they take it on the y-axis and the imaginary axis. All the calculation requires the vector algebra, the trigonometry. And in LCR circuits and electromagnetism, all these calculations require this I. And these I becomes the real number, right? So in equation, somewhere it will be multiplied, and this imaginary plane will give the component of real ones, right? And that way people have invented a lot of functions too. So we'll talk about functions, right? So earlier, when people used to measure the distances, they find that they have similarity in their relation between length and angle. So by using those principles, they can measure a lot of big heights like pyramids, or they can find the distances between stars, you know. So all those happened because of they finding the relation between angle and length, and this relation are defined by sine function, cos function, tan function, right? So these have been invented, and these have been modified like one unitary circle, and this component will be defined as cos theta, this component will be defined as sine theta. And using the same principle, we've invented you know the vector algebra too. Let's say if someone is pulling this block on F1 and someone pulling in that direction, the resultant will go in this direction. And how will you find out this direction? So using the trigonometry again, right? The trigonometries, and we've found one vector algebra. So we've invented that way. And we use the same trigonometrical principle in imaginary numbers calculation, the vector algebra calculations, and so in trigonometry as well. And to in astronomy, people have find the problems calculating in large numbers calculation. It took hours and days, and that made them, lost the significance of time in order to predict the astronomical behavior. So they needed something that can ease their calculation. So that way they define the logarithm. Logarithm, if you read in Hindi, it's called lagu gadak. That means gadak means calculations, lagu means minimize or small or optimize, you can say. So making multiplication, making calculation easy, we've हमने logarithmic इजाद किया. And how it happens is just convert long powers into simple multiplication. So we have defined like this. So see, only the power will matter. So how so exponential functions calculations, it made so easy. It's inverse function of them. It made so easy, like converted this 9. And just we need to have the log table and anti-log table, which has been defined by using the logarithmic principle. Let's say you have log under root 10, so that means it becomes half. And real log, this one is 3 point something, right? So we have defined that anti-log of 0.5 will become 3.12. So by using these functions, we've made calculation so easy, and the other principles as well, that log a plus log b becomes log a into b. So these things we can use, like log 10 to 27. You have to find out. You can write it 3 log 3, and there are a lot of other things we can do using log and make calculation simple. In a similar fashion, let's do some of the numericals on number system, or discuss the concept in number system. Like we've read the divisibility rule in our childhood. We read about the divisibility rule, but we never understood how we made the rule. Let's say any number would be divisible by 2 if z is divisible by 2. The unit number is divisible by 2. Why? Why? Because we know that every number has the interval of going 2, right?
So any number will go with 2. So any big number, if you let's say it would be 102 plus 1. So their unit has the component of 2, and 2 goes from like 2 to 2, 4, 6, 8, 0. So all these unitary number, if we can see on the unit side, that means that that number is bundled on 2. So the remainder would be not would be 0, and we can say the number is divisible by 2. What about the case in 3? We say when the summation of the number of all would be divisible by 3, we can say that this number would be divisible by 3. Why so? If you carefully note, we can write this number as 100a plus 10b plus c, right? And we can write as 99a plus 1a plus 9b and b plus c. And if you can separate it out, a plus b plus c will come the around 99. So you know this is divisible by 3, and if this component has 3 or 6 or 9, or if it can be divided by 3, then whole number can be divided by 3. And same with the 4. You know, we say if any number is there, it is divisible by 4 only if the last two digits can be divided by 4. Why so? Because we know 100 is divisible by 4, right? So any number will have the 100 component. So let's say if you write this 10y plus z, so this would be divisible by 4. So this component becomes yz, and if this is divisible by 4, only then total number can be divisible by 4. Same way 8 can divide 1000. So any number is divisible by 8 only if their last three digit is divisible by 8, which means except leaving their 1000 component, the other component, if they can be divided by 8, the whole number will be divided by 8 because it's already divided by 8. And so we look at the last three components. And let's say for 11, the rule is that the sum of odd number and sum of even number, if we difference it, make the difference, if resultant comes 0 or divisible by 11, the whole number will be 11. Why? If we write this in a manner, let's say this is 100x plus 10y plus z. You know, if we can write it like 11 minus 1, right? So 11y minus 1y, right? This we also can write 10x and into 10x. So nothing but 11y minus 11x minus x into 11x minus x. So nothing but that minus 1 part, if you take the modular function, will come twice, right, at x. Here it will come 1 at y plus z. So if we see, this will carry like this if any other number, and then so all even part would be positive, or all even part would be negative, all odd part would be positive. So summation would be minus plus minus plus. So if you add the all plus and divide minus, if it comes 0, that means all number are already divided by 11 because there's nothing left. And if it is come as 11, the sum, that means already divisible by 11x, that can be divided by x, plus this 11 component will come and total number would be divided by 11. That way we can find the rule for 7, 13, and we can make the divisibility rule and can play with it. Even we can make divisibility rule for binary numbers, right? In fact, these concepts are used in algorithms and computer mathematics, right? So we've seen that in order to solve problems, we invent mathematics, and mathematics has not stopped. It's being invented now also. The topography, where we decide that, let's say this is curve, so it's part of one sheet, right? This concept, like how it is related, these concepts are being discussed in topography, and this mathematics branch will again solve the problem of space-time fabrics, right? We know that space-time are complementary, and they are the time is the part of fourth dimension. Like, let's say if space is if you are moving into space, the time becomes slow for you, and then if you are if you're not moving in space, time become uh, fast for you. So they means their summation is like constant. They are so interconnected that this will be constant. They'll be a complementary. I'm adding it, but they are in total different dimension. We can't add like algebraic summation, but the feeling is that they are complementary, that if you increase one, the one has to adjust in order to make this constant. The other part of mathematics are graph theory, information technology theory, where you find how to minimize the bits for the programming or the software. And then there's the nodal theory. We know that everything is connected. Every node has certain tendency to, let's say, have 30% probability, 70%. What if at this node this gets selected, at this node this, and then making them, they will again give the some probability. So for chaotic theory, complex things, we discuss the node mathematics branch. So all right, thank you for watching this. Maths are being invented. I hope you also invent some branch. And yeah, it's very convenient to invent math to solve the problems which are arised in physics, engineering, or we can derive the abstract mathematics which we'll have later use. And these mathematics branches are evolved, and they become the sophisticated tool for solving the engineering and physics problem.
या मिलते हैं अगले वीडियो में. थैंक यू फॉर वॉचिंग.